And last we have example 4. So again, I would suggest pausing the video and trying to identify the excluded values as well as the LCD before continuing on. So go ahead and hit pause at this time. All right, so you should have paused and figured out that in this case we're talking about y. And since again the denominators are not factorable here, our excluded values are just -3 for the one on the left. And if we set 6y plus 5 equal to 0, we're looking at -5/6. And again, I'm going to highlight those so we don't forget at the end, that is our no-no list. So if we get either of those numbers, it's not part of our solution set. And then for LCD, it's just the two factors put together. And then think about what are we going to do next? Well, at this point we have the LCD, so now we need to get rid of the fractions. So we're going to multiply the LCD by every single term. In this case, it's just once on the left and once on the right. So over here, over on the left, we'll go ahead and multiply by y plus 3 times 6y plus 5. And same thing on the right, y plus 3 times 6y plus 5. And as has happened in the past, the denominator cancels over here with the y plus 3. Denominator over here cancels with the 6y plus 5. And in this case, we're back to that example where we just distribute these two values into the remaining binomial on each side. So we're going to have 12y plus 10 equals y squared plus 3y. Now, in order to solve this thing, there's no like terms, so we don't have to worry about that. And this time, just like we talked about in the last example, because all we had to do was distribute, and we distributed a y on the right-hand side, there is this y squared term. So in this case, I'm going to be solving a quadratic. Now, the odd thing about this one is that there's only one y squared and it's on the right-hand side. So I'm going to choose to move everything from the left, the 12y and the 10, to the right-hand side to keep that y squared term positive. So I'm going to start by subtracting 12y on both sides. So we'll get 10 equals y squared minus 9y. Then I'm going to move over the 10, and the reason I'm doing this is so that now we have 0 equals y squared minus 9y minus 10. And we need that because now when I factor what's left over, I'll have factors set equal to 0. I can set them each equal to 0 and solve. So next we need to factor the trinomial. So build your x. If you want to pause the video and come back and check your factors when you're done, that might be a good idea. On the top, we'll have a -10. On the bottom, we'll have a -9. Numbers that multiply to -10 but add to positive, or -9 rather, 1 and -10. And now we group. So y squared plus 1y minus 10y minus 9. First two terms share a y, so we'll take that out. Second two terms, they're both negative. If I want y plus 1, I need that negative out. And shoot, I missed that this shouldn't be a 9. It should be a -10. Otherwise, that wouldn't have worked. So we got to take out a -10. Now there's something they have in common. So y plus 1 when I take out -10. So now they match. And that means, if I come back to my problem, this factors to y plus 1 times y minus 10. Set that equal to 0, and if I set each one equal to 0, y plus 1 equals 0, y minus 10 equals 0, what are the two numbers that I'm going to get as a result? Well, you should have found that the two numbers are going to be -1 and +10. Now, last check is to go back up to the top here and look at our domain exclusions, -3 and -5/6. -1 and 10 are not those numbers, so these are the solutions. In this case, again, there's two, to our rational equation. So that's it for today. You'll see there's a practice problem or two here at the end for you to try in the play pause it, and then get ready because tomorrow we'll be adding on to this concept. All right, good luck.